This is June 2024 paper, Unit 6. So they are saying question number one, an organic compound A is a liquid. It contains two functional groups. The tests are carried out to identify A. Test 1, a small amount of phosphorus chloride is added to 2 centimeter cube of A, or observation, misty fumes given off. Misty fumes given off. You know,
OH group, the
carboxylic
alcohol.
acid. Yeah, you can
Yeah,
say alcohols, right?
yeah,
So it's due to the presence of OH.
OH
It's
group.
due to
Yeah,
the presence of identify by the name or formula. The functional group identified by these tests justify your answer. And also they are saying that
and it
it's going to react with sodium hydrogen carbonate. It's a weak base. It's
yeah,
a
and
weak base.
also when sodium hydrogen carbonate is reacted with carboxylic acid, CO2 is released, but in this case there is no visible reaction, so it is an alcohol.
Exactly, exactly. So means that it's not a carboxylic acid because it's not going to react with sodium hydrogen carbonate. Okay, because
Yeah.
so it's of 2 marks. So first of all, I'm supposed to write uh, due to the presence of OH, like misty fumes of HCl given off due to the presence of OH
OH.
functional group,
Yeah,
but not carboxylic acid,
yeah,
as sodium as no reaction with NaHCO3. Then they're saying test 3, a few drops of A are added to 2 centimeter cube of Tollens reagent, ammonical silver nitrate solution. The mixture is placed in a warm water bath. Observation, silver mirror. So I told you that silver mirror is an oxidizing agent, so it can only react with an aldehyde because aldehydes can be oxidized, but ketone does not. So it
yeah.
would be only reacting with aldehyde. So identify by the name or formula, the functional group identified by this test. So I'm
COH.
supposed to write aldehyde because they are saying by the name or formula, aldehyde.
Yeah,
Compound A is non-cyclic, okay, and its mass spectrum has a molecular ion peak with mass to charge value of 74. Molecular ion peak is going to tell you the overall molecular mass of a compound.
yeah.
So draw the displayed formula of the two structural isomers of A using this information and your answers from A and B. Using your answers from A and B. So means that in A we identified alcohols, in B we have identified aldehydes. So then compound A is non-cyclic. Like non-cyclic means that it's a straight chain structure. Okay, it doesn't
Yeah.
have any cycle. So draw the displayed formula for the two structural. Structural has three types: chain isomer, functional group isomer, and positional
Positional
isomer.
isomers.
So and also they have told you the overall molecular mass of a substance, that is 74. That is 74. Okay.
Yeah.
So means that, and it is understood that it's going to contain the two functional groups. Number one, OH. Number two, C double bond H. Isn't it? Yep.
Yeah.
Am I right? Okay.
Yeah.
So then 74 74 minus 2 oxygens, and 2 oxygens 32 and minus 2 hydrogens. What's the answer?
1 second. 70. 40.
40.
40.
40 divided by 12 because the mass of carbon is 12. So what's the answer?
3.3.
Means 3 carbon atoms. So 12 into 3, 36. So 40 minus 36 is equal to 4. So means it's supposed to have 4 hydrogen atoms. Furthermore, so first of all, I'm supposed to write down the formula. Carbon, 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 carbon. This is aldehyde. This is aldehyde. And this is going to have OH. Okay. This is going to have OH. That's the formula. That's the formula first. So is the molecular mass 74? Is the molecular mass 74 if you can count this?
12 plus 12 plus 12 plus 1 plus 1 plus 1 plus 1 plus 1 plus 1 plus 16 plus 16. 74. Yeah,
Yeah, okay, good.
74.
Then we are supposed to draw the two displayed like structural isomers. Okay, so
Yeah.
the first one would be straight chain isomer. Okay, they are saying the displayed formula, each and every bond must be shown, and then the other isomer should be 1 2. Three carbon, 1 2 3 4 5 6 hydrogens and O2. Three carbons, 1 2 3 4 5 6 hydrogens and O2. Molecular formula is same, but the structure is different. So that's why they are structural isomer. And this is the chain isomer, the chain length is different basically. The chain length is different. Okay. In the functional group isomer, the molecular formula would be the same, but the functional group would be different. And in positional isomer, the molecular formula would be the same, but the position of the functional group would be different. Are you getting my point?
Yeah.
Okay. Or, yeah, you can see this one. It's of only 1 mark. Yes.
Yeah. Relative peak area. Low resolution.
They are saying a low resolution proton NMR spectrum of A shows 4 peaks with relative areas of 1 is to 2 is to 2 is to 1. Deduce which of the structures in C part 1 is correct. Oh, okay. By identifying the relative peak areas on your formula. So basically 1 is to 2 is to 1. 1 is to 2 is to 1. So I can say that I can say that uh, number one, 1, okay, and these are the 3 hydrogen atoms. No, it's not correct. Am I right? Yes or no? They were saying 1
Mm,
is to 2 is to 2 is to 1.
yeah.
1 hydrogen, then 2, then 2, then 1. It's not correct. They are 3. 1 is to 2 is to 2 is to 1, isn't it?
So can you just
So
like just explain again what is this low resolution and high
basically,
resolution proton NMR?
basically in NMR spectrum, as I told you that in this we are supposed to identify the uh, you can say uh, how many environments we have. Environment means that let's suppose this is the first environment. I'm
Mm.
looking at the proton only. Sometime they will be asking for the carbon as well. And this is another environment for the three hydrogen atoms. This is another environment for one hydrogen atom. This is another environment for one hydrogen atom.
Yeah.
So there are one, two, three, four environments in total. You know, the environments for these three hydrogens are the same. If you ask why, because the neighbor is the same.
Everything.
Because the neighbor is the same. This hydrogen is also connected towards the carbon, the
Yeah.
same, the same. So means that the environment would be the same. So we are looking at this one. So I can say that it would be 1 is to 1 is to 1 is to
Is to
3,
three.
isn't it? Yeah,
Yeah.
exactly. So so they have told you that thing in this question. What you have to do, you have to only you have to only match this thing with the given compound. So they are saying deduce which of the structures in C part 1 is correct by identifying the relative peak areas on your formula. So the peak areas are 1 is to 2 is to 2 is to 1. That is 100% matching with this structure. So that's why this structure is correct. Are you getting my point?
Yeah.
Yeah, exactly. So I would be drawing this structure simple. I'm
Yeah.
going to copy this one. Oh, yeah. So this is, or I can say, this one.
1:2 is to 2:1. Yeah.
Okay, it's of 1 mark. So that's the structure
Yeah.
is correct. Um, okay. A series of experiments is carried out on an aqueous solution of chromium 3 salt B. Experiment 1, experiment 1 to a sample of solution B, aqueous sodium hydroxide is added drop by drop until in excess. Complete the table given. Giving the observations, you would see observation on adding a few drops of sodium. I told you in the last class as well, if you remember, I told you different tests, copper, chromium. Do you remember?
Yeah.
Iron 2, iron 3, excess sodium hydroxide, few drops of sodium hydroxide. So the same question they are asking. We have chromium 3 plus as they have given to you, chromium 3 plus. So when you will be adding few drops of sodium hydroxide, so I would see green precipitate for the chromium hydroxide, green precipitate for the chromium salt, and observation on adding an excess of sodium hydroxide. So I would see deep, or you can say the dark blue solution. If you remember when we were
Hmm.
using copper, when we were using copper, first of all we saw blue precipitate. First of all we saw blue precipitate, and then we saw the deep blue solution. But this is not copper 2 plus, it's chromium 3 plus. It's
Hmm.
chromium 3 plus for chromium 3 plus. So we are looking at the green precipitate, and also after the addition of excess sodium hydroxide, we are looking at the dark, or you can say the deep green solution. That's the difference between the copper 2 plus and the chromium 3 plus. And what about the state? What you can deduce about the nature of chromium 3 hydroxide from
Basic.
the results of experiment 1? Yes,
Not sure.
you were saying basic.
I said basic first, but now that I think about it, I don't think it's right.
Basically, you can see it's reacting with aqueous sodium hydroxide drop by drop until in excess. Okay, until in excess.
Hmm.
Copper 3 salt. And also, we can add hydrogen chloride. If you remember, I told you after the addition of hydrogen chloride, like hydrochloric acid, so we were getting the yellow solution. means that this salt is going to react with base as well, and this salt is going to react with acid as well. So what's the nature of the compound? If it would be reacting with the both, so I can say it would be amphoteric, isn't it? Isn't it?
Amphoteric, yeah.
Amphoteric, yeah, exactly. So this is amphoteric in nature.
Can act as a base or acid, yeah.
Yeah, dual nature, like a metalloid. So, like metalloids can react, like metalloids can act as a metal or as a non-metal. So it has a dual nature. So the same goes with this one. Experiment 2, 5 cm cube of hydrogen peroxide, okay, is added to final mixture formed in A part 1 and heated gently. A yellow solution containing chromium 4, 6 ions is produced. Explain the role of the hydrogen peroxide in this reaction. Justify your answer. So initially, I had chromium 3 plus.
Hmm.
Initially, as they have told us. Initially, I had chromium 3 plus, but now I have chromium 6 plus. But now I have chromium 6 plus as they have told us. Chromium 6 plus, plus 6. Means that,
It's been oxidized.
so who did this? Who
The
did this?
hydrogen
Of course,
peroxide.
hydrogen peroxide is hydrogen peroxide, or I can say this is being oxidized because the oxidation number has been increased. So H2O2 is an oxidizing agent. Okay,
Hmm.
it's an oxidizing agent. Simple.
Yeah.
Experiment 3, dilute sulfuric acid is
Wait.
added to
Ah,
the
yeah,
yellow.
yes, yes.
Yeah. Okay.
No, 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 no. Correct,
Experiment,
correct.
no? Okay.
Understood, understood.
Experiment 3, dilute sulfuric acid is added to the yellow solution formed in experiment 2. The solution turns orange. Okay. Complete and balance the
Orange.
equation. Oh my God. State symbols are not required. Okay. So CrO4 in that, the chromium is plus 6, of course. So we have to write down the formula of the salt
Cr2O7.
in which chromium, in which the in which we have to write another compound of chromium. So dilute sulfuric acid is added to the yellow solution. So the yellow solution is this one. So the yellow solution is this one, okay? So in this solution, we are adding sulfuric acid that is represented by this H positive ion. And in this, the oxidation number for chromium is plus 6, isn't it?
Plus 6, yeah, yeah.
So so then it would be changing. I can say that turns orange. Orange. So orange means that it's gonna be K2Cr2O7. Like I want to write Cr2O72 minus, because this is orange. CrO4. This is orange. What's the oxidation number in that for chromium?
Cr2O7.
And in experiment 2, they were adding. Yeah, okay.
But shouldn't there also be H2O?
Yeah, H2.
Okay, so 2C, so then it'll be 2CrO4.
Yeah, exactly.
And then 2H2, 2H plus, sorry.
So 2H, 2H, 2 chromium, 2 chromium, 2 into 4 is 8, 7 and 1 is 8. Yeah, okay. This is balanced equation. Question number 3 says a group of students carried out an experiment to investigate the reaction between potassium manganate, that is KMnO4, and ethane dioate ions, that is this one. So this is your potassium manganate, and this is your ethane dioate ions in acidic condition. Procedure step number 1: measure 10 cm cube of potassium iodide solution into each of 8 conical flask. And okay. Measure 100 cm cube of this one, this one, this one, this one, this one. Explain why step 3 Explain why step 3 effectively stops the reaction between potassium manganate and ethane dioate ion. Step 3: immediately withdraw 10 cm cube of reaction mixture and and add it to the first conical flask containing excess potassium iodide solution. So, so first of all, what's the nature of Ki? What's the nature of Ki? That is potassium iodide. Ki is this one in which iodine is minus potassium iodide. Of course, it would be changing into I2. Of course, it would be changing into I2. So
Hmm.
I2 means that in which the oxidation number would be zero. It's changing from -1 to zero. So what does it mean? It's being oxidized or reduced?
It's being oxidized.
It's being oxidized, yeah. So means that it's a reducing agent, so it would be an oxidizing agent, okay?
Yeah.
Because they were saying measure 10 cm cube of potassium iodide into each of 8 conical flasks, measure 100 cm cube of ethane dioic acid into 250 cm cube beaker, add 25 cm cube of potassium manganate solution and 5 cm cube of sulfuric acid, mix the contents, okay, and start a timer. Of course, Mn2 plus would be formed, carbon dioxide would be formed. Immediately withdraw 10 cm cube of reaction mixture. Like I have to put out 10 cm cube of reaction mixture and add it to the first conical flask containing excess potassium iodide solution. So Mn2 plus, in this I would be having Mn2 plus, okay, Mn2 plus Ki, isn't it? Mn2 plus and Ki, because in step 2 the product would be formed, or they are saying immediately withdraw. Immediately means that like the reaction is about to start, but
Hmm.
immediately I have drawn 10 cm cube of reaction mixture and add it to the first conical flask containing excess potassium iodide. So what they are asking, explain why step 3 effectively stops the reaction between potassium manganate, like potassium manganate and ethane dioate ions. Why? Number one thing is that when you would be having potassium iodide, when you would be having potassium iodide and KMNO4 and KMNO4. So you know what it would be doing? It
Hmm.
would be forming I2 and Mn2 plus. Because in this we have Mn is that is plus 7. It would be
Okay.
changing into plus 7 to plus 2. Means it
Hmm.
would be reduced.
Medius.
So this is a
Okay.
reducing agent and it would be oxidized. So means that this is an oxidizing agent. This is reducing agent, isn't it? Okay. But I have removed 10 cm cube of reaction mixture. So it's mean that there is no such KMNO4, that is potassium manganate, to react with this one. So of course they are saying right, it would stop the reaction between potassium manganate and ethane dioate ions because
Hmm.
you know why? Because potassium iodide would be reacting with this one. So there is no one to react with this one. So that's why reaction will stop.
Yeah.
Right now, they both are reacting with each other, but when you will be adding potassium iodide, so potassium iodide will react with this one. So in other words, I can say it will used up. It will be used up. Why? Because it would be reacting with the potassium iodide. So
Hmm.
then, if it would be used up, so with whom this C2O4 is gonna react? Nothing is left. So the
Yeah.
reaction will stop. Are you getting my point?
Yeah.
Okay, so what am I supposed to write over there? I'm supposed to write potassium iodide will react with potassium manganate, that is MnO4 minus. Okay, so after the reaction, after the reaction, all MnO4 minus is used up, is used up. Okay, so the reaction
Comes to an end.
between MnO4 minus and C2O42 minus will stop.
Mm.
State when the starch indicator should be added during the titrations in step 5. What's going on in step 5? In step 5, that they are saying that using starch as an indicator, titrate the iodine form. As I told you, iodine will be formed, because iodide would be changing into iodine. So
Yeah.
iodine would be formed, titrate the iodine form in the conical flask with aqueous thiosulfate, like this one. This is the reaction between the thiosulfate and the iodine. So when the
Colorless.
starch, hmm? Sorry?
Is it when it's colorless? The answer.
When the starch indicator should be added during the titrations in step 5. So basically, whenever I can say that, what's the color of iodine in aqueous form? What's the color of iodine aqueous? It would be, I can say, the yellow solution near to.
Yellow.
Okay. So,
Isn't it
so
colorless?
as the reaction proceeds,
Isn't
as
it
the
colorless?
reaction, no, 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 iodine is colorless in
No, no,
aqueous
no.
solution.
When uh,
When
uh
iodide is formed.
yeah.
Yeah, but of course, uh, the product would not be formed suddenly, of course.
Mm.
Gradually, the product would be forming as the product is being formed. So, what does it mean? The quantity of reactant is going to decrease. Am I right?
Mm.
When the quantity of reactant is going to decrease, it's mean that the quantity of iodine is decreased, isn't it?
Yeah.
When the quantity of iodine is decreased, of course, what would be the color of the solution? What would be the color of the solution? So I would say pale yellow. The solution will turn to pale yellow. The solution will turn to pale yellow. So whenever the solution will turn to pale yellow, so then starch indicator should be added during the titration in step 5. It's of
Mm.
only 1 mark because iodine and starch indicator, they can make a blue black complex. That's why we add starch indicator. Starch indicator and iodine, they both react and they are going to form a complex. So the color of the complex is blue black complex. Okay,
Mm.
so that's why. um so if you will be adding starch indicator and if it would be forming a blue black complex, what does it mean? It means that still iodine is left. That's why it is reacting with the starch indicator. And if there is no color change with the starch indicator, so what does it mean? All the iodine has been reacted with that thiosulfate ion.
Mm.
Okay, so that's why in step 5, starch indicator should be added during the titrations. Okay, so I'm supposed to write when the solution turn to pale yellow.
Okay.
Oh, graph. Okay, will you be drawing this curve? Should I skip this question?
Yeah.
It would take
This is easy.
it would take so much time. Yeah. Okay. So
Yeah.
then describe how the rate of reaction. Of course, this reaction is related to the graph. Explain why the rate of reaction. Okay. 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 Now this one. Question number 4 says this question is about the laboratory preparation of the ester methyl salicylate oil of. Okay. Okay. Show by calculation that the methanol is in excess in this preparation. Excess reactant and limiting reactant. Limiting reactant is the one which consumed first, and excess reactant is the one which is not consumed. It would be left behind after the end of reaction. So then what am I supposed to solve? Like, how am I supposed to solve this question? First of all, can you tell me the mole of salicylic acid? Mole of salicylic acid, that is equal to the mass, given mass. What's the given mass of salicylic acid? 20 grams. Okay, they have given the mass of salicylic acid, that is 20 grams. And what's the molecular mass for salicylic acid? They have given us 138. What's the number of mole? What's the number of mole of salicylic acid?
I might have eight moles. Wait,
Yes, what's the answer?
1 second. The answer is 0.1455.
0.14145 mole.
Yeah.
And mhm. Okay, they were asking methanol is in excess. Okay. So 20 gram of salicylic acid, methanol is this one. Okay, salicylic acid is this one, and the mole ratio is 1 is to 1. And the mole ratio is 1 is to 1. Okay. They have given you the volume of methanol, that is 100 centimeter cube, or okay, density is also given to you, that is 0.791 gram per centimeter cube. So I can find out the mass of methanol. How? It's very easy, because you can see 0.791 grams per centimeter cube multiplied by 100 centimeter cube,
Hmm.
because the volume of methanol is given. Cm cube cancelled. The answer would be in grams. What's the answer? It would be, of course, 79.1. Okay.
Sir,
Yeah.
can you just give me 1 second? I'll just use the washroom and come.
Okay.
Hello? Hello?
Yes. Okay. So I told first of all you have to find out the mass of methanol, or then
Mm-hmm.
you can divide it by their coefficients. You can divide this question by their
Mm.
coefficients. After dividing by the coefficients, when you will be getting the large answer, when you will be getting the large answer, so that would be in excess. When you will be getting the lower answer, so that's gonna be in a, is a limiting reactant. Yeah, that's the method to find out the limiting reactant and excess reactant. Okay, so that's why we will be finding, and we got the mass of methanol, we can find out the moles very easily. After getting the moles of both, so we can divide the mole by their coefficients. After dividing by the coefficients, we can see the lower and the larger number, so we will be getting the answer. That's it.
Yeah.
Okay. So I'm just uploading this. I have recorded,
Mm.
or inshallah, then we will be doing the same thing in the next class. Now we have three classes, right?
Mm.
Okay. Okay.
Sir?